Hello everyone, thank you very much for joining me again for this Software Architecture Fundamentals stream episode number 3. We are going to discuss today a continuation of the architectural styles, and we continue with software-oriented architectures. This is our next step further. First of all, however, I would like to answer a question that I got this week in regards to modules using Maven versus Jigsaw. Yeah, that's the first thing I would like to take with you for the moment, and then we will continue our discussion splitting our monolith into services. So I hope the sound is better now because I muted my my notebook. And yes, as I can see already, many of you are watching the event live. So if you are watching the event live, as usual, I tell you, leave your messages in the live chat, because I'm always keeping an eye on the live chat. So I will try to, as much as possible, answer your questions while they flow. And if you are watching the event recorded, of course, I still give you the opportunity to always leave any kind of question in the comment section, or you can find me on LinkedIn or on Twitter, and we can discuss there as well. That's basically how I got this question for today. I'll try to answer the question, and then we'll go further to discussing architectural styles. Let's take a look on what I have here prepared for you already. And again, the first thing is discussing again. I'm just trying actually to show it in an example, because I understood it wasn't really clear what's the difference between using Maven modules versus using a Jigsaw approach in a Java application. And I know that's not really necessarily software architecture fundamentals, but as I told you in this stream, because I'm a Java developer and this is basically my specialty, you will find plenty of examples that are coming from the Java ecosystem, because that's basically what I know the best. So now what I want to show you and to enforce again is the fact that you can use basically two different modular approaches to separate the code in your monolithic application. Remember that a monolithic application contains all the features in the same process. So when you have all the features, you have multiple responsibilities together, you deploy them as only one artifact, or not necessarily on only one artifact, but in only one executable artifact, maybe it's better to say, so one process. Then you call this application monolithic. And we discussed already in the first 2 episodes, you have some concerns, and we have to take into consideration some concerns in regards to the monolithic application. And one of the concerns was the fact that the footprint is large. So being larger is of course more difficult to deploy. Another concern is that it's more tempting for the developer to break principles of clean coding and clean design and create a spaghetti code application, by basically couple too much the responsibilities, and of course by that decrease the maintainability of the application. So I suggested 2 approaches to modularize your application from the Java ecosystem, and now I want to basically show them, because I didn't show them at all in the previous episodes. I didn't discuss at all these approaches in terms of like showing an example in a project, and I will start with this today. I will show you an example, so I make sure everyone knows what Maven module is versus a Jigsaw application, and then discuss again the differences between this kind of making your application modular. And then once we clean up with this subject, and hopefully I will manage to answer all your questions that you had and you asked me in the previous week on LinkedIn and Twitter, I will then further go to service-oriented architectures, and we will discuss how the service-oriented architectures appeared in terms of the history of software architecture. And then, of course, step by step, we'll go through different benefits as well as concerns we have with the software architecture, software-oriented architecture styles, and discuss, of course, how to solve the concerns, or what are our possibilities in making the systems better. And you will see, we will dig into the subject. Now, I would like to just create a Maven modular application to see how it looks like. So let me see, say here is modules E1 from example 1, and this is how in Java, for example, I will just replace this window, and you can create a Maven application. It can be, then you can use any dependencies in your POM XML, but what's most important for our demonstration here is to prove that you can modularize the application using Maven. So in terms of using Maven as a build tool, you can anytime just add new modules to your application. So instead, even if you have a monolithic application, you don't have to put your code all together into this Java folder of the only existing Maven project you have. So instead, you can have a project that is designed in multiple modules, and you can separate the responsibilities in the modules. So we will see what you achieve using that. One of the things you achieve is, of course, separating the responsibilities, which in terms of organizing better your code helps you keep your application easier to maintain. So it's somehow it's not that tempting anymore, like in general monolithic applications are, to couple the responsibilities. If you make them too tightly coupled, the responsibilities, then it's very, very difficult to take one of it apart and understand it. And one of the main things you'd like to do is make sure you somehow keep all your responsibilities apart. Thank you very much, Dominic. I hope you will like the book, The Spring Security in Action. So I'm going to just assume this is my monolithic application that does a lot of things. It has a lot of responsibilities, but I will only demonstrate, of course, 2 modules, because we don't now have the time to implement a huge application, and it's only a demonstration. So I will say it's a big application that, besides many other things, it does invoicing and delivery. Maybe it's an online shop, maybe it's something managing products in a supermarket. We don't care that much, but it has a lot of responsibilities, and 2 of these responsibilities are invoicing and delivery. So what I will do, instead of just creating a couple of packages here, because I could actually have created just in my Java folder here, just create the packages, say invoicing and delivery, and just put the classes all together in the same project. A better approach, if we know we have a monolithic application, is simply separate the responsibilities in modules. So what you do, you just go here, you select module, and you select Maven module, and then you can create separate one for invoicing, and then you just create one more module and you call it delivery, and then you can have any modules. You can have as many modules as you need for all the responsibilities in your project. So you see, instead of putting everything here, now this is called the parent module, and it has its own POM file, and inside you see that all its children modules are enumerated here in the modules tag in the POM XML file, and then each of these it's a different project. They have their own dependencies. They are somehow independent responsibilities, and it's easier to see their independence. So because you will implement the code as well as the tests per module, And this makes also the implementation again a little bit less tempting in terms of mixing the responsibilities, because it's then when you will have to refer from one module to another, you will see that you will have to add one module as a dependency to the other, and that basically will light a bulb and tell you, should light a bulb and tell you, are you sure you want to mix these responsibilities? Are you sure it's pretty necessary they call each other? If you do that, should you maybe use an interface between them, because interfaces are contracts in Java? So maybe it tells you, here you do a bridge between two modules. It's easier to see that you have two responsibilities. So when you see you have to do a bridge between two modules, then you instantaneously realize that maybe you have to do that via an interface, which is a contract. So you see, it's just organizing the code, but it's much easier to see that you have to organize the code. So I often see Monolith split in modules by tier, front-end, back-end entities. Is this a good idea? Honestly, I don't really prefer doing that, because I mainly see responsibilities in terms of functional groups of use cases. So I don't see a reason why I would put separately the services. Let's say I put the services separately. If I put all the services separately, then I have all the use cases there. So then I will again continue to be tempted to call a use case from another, so mix the responsibilities. But in case I separate in terms of business logic, then I definitely see when I call a use case from another use case that are in separate boundaries. So that's where you separate the boundaries. And by the way, in regards to boundaries, we will discuss in the next episode how to find out the boundaries and different techniques as domain-driven design to find out the boundaries. When you have boundaries, what I see relevant in terms of software architecture is kind of separate them by the boundaries you see in terms of responsibilities. So I don't see a lot of advantage separating the, say, repositories, entities, services, controllers. I basically can separate them by module anyway using packages. But when I think in terms of modules, I prefer to find the domain and restrict that domain, so that when I do coupling between two different domains, I first of all ask myself the question, is that really needed? And secondly, if the answer is yes, then I decide whether, and in most of the cases I do need to use a contract in between, so use an interface, again to maintain the decoupling of the modules. So in terms of modules, in example 1, Maven modules, you don't do a lot of things in regards to showing the properly the dependencies between the modules, because you see you have no way other than investigating the code itself to see the dependencies between the modules. But at least it's easier to group and organize the code by using modules, so that it makes more clear for you which are the boundaries when you write the code. Those boundaries that you might have at some point written in a diagram, in an architectural diagram, you now see them in the code, in the project itself clearly, and it makes your decisions in terms of implementation easier as well. So that's what you gain with using Maven modules. But let's see also the second approach. The second approach I discussed, again, we refer to the Java ecosystem, but I'm definitely sure if you, for example, are not a Java developer, you will find similar ways in your platform as well. Well, the second approach in a Java ecosystem is using what we call the Jigsaw project. That is a feature, a very important feature, basically one of the biggest since Java 8. It appeared in Java 9, and it allows us create modules in the Java application itself, and this is how it looks like. And now you will see also what's different, what's the difference with the Maven modules. So modules E2 is my second example, and I want a new window. I want to keep them both, and in my modules E2 you see it's not I explicitly didn't create it anymore a Maven project, because one interesting thing is that you can mix these approaches. I don't want to put you into a fog now, and I want to not mix the approaches, but you are not forced not to have both Maven and Jigsaw at the same time. But I want to show you these approaches separately. So now I created simple project. It's not a Maven project. You see, we don't have any POM XML. We don't use a build tool. However, starting with Java 9 and upwards, you can create modules here as well. So now I would just say I want to add one more Java module, which is invoicing. I will keep the same names as in the other project, and the second one I call the delivery. So this is the delivery module. And taking a look inside, you will see that both of them have their own sources. And first of maybe the most important thing to take into consideration is that these are not the real Java Jigsaw module unless you create inside a module info file. This module info is very important. So what I'm going to do next is add to both of them this module info file that has the only mandatory thing it needs to contain is the name of the module itself. But what's really important here, say this is a monolithic application, again you have some classes you create. Say I have here I don't know, package, invoicing, services, and I create just a demo service. Let's call it delivery service. And then I do the same thing here in invoicing, and I create a package that I will call invoicing service or services, whatever, and say this is an invoice service. And say I want to use the delivery service inside the invoice service. Now, one important thing is that if you try to use it here like this, delivery service, you see IntelliJ doesn't even show me I have that option, because at the moment I don't have the option to do that. And this is one of the most important differences, is that if I would have done the same thing here, the only thing I need to do is add a dependency between the invoicing module and the delivery module. But if I'm going to Jigsaw, then one of the things I really need to do is in the module info file, I always need to declare all the interfaces in terms of what a module exposes and what a module consumes. And this creates a really nice graph that not only allows you easier separate the code, but it definitely forces you see when you have dependencies between modules. So when you see the dependencies between the modules, you can even decide from the class design point of view if you properly fulfilled all the rules you wanted to fulfill in terms of coupling between your responsibilities, which you can decide while working on the architecture itself of the application. So it's a much better way to see. So say I want to use, and what I need to do is now I really need to say exports, for example, here, and I really need to say what exactly it exports. So in my case, I say I'm exporting this package, and then from this other one I need to say it requires, and then I have to say it requires my module, in my case called delivery. Okay, and you still see I still need to add a dependency to this one, and this dependency is added in a separate kind of a path that we call the module path. And that allows us a second important thing, not only that now to use this to make this module dependent to this one, I really need to explicitly say what is exported and what is consumed. But more than this, I actually can decide if I want to deliver or not a specific module. And now, besides the modules I have created here, I was saying in the previous episode that the JDK itself became modular. So you see all these folders here, they are equivalent to these delivery and invoicing folders we have here. So you see they are basically represented the same way by IntelliJ with this blue rectangle, blue square here in the right bottom corner of the folder. This means it's a module. And with the modules the same, you see basically the JDK provides you with plenty of functionalities. Some of it you never use. So maybe the Java XML and the Java XML crypto say this is a dependency you don't even need to use in your application. What the Jigsaw modular system allows you is now you can actually create an application where you only get the modules you need, both from the JDK as well as from those modules you create. So now, in case of Maven modules, you don't have the possibility. It's much more difficult, and you usually don't do that. You don't separate the modules. It's still a monolithical application with all the modules. You still have to deploy all the application. When using Maven modules, the only benefit you get is that you separate the code, you better organize it, and then that helps you, of course, keeping your application more maintainable. But when using the second approach, that is the Java Jigsaw approach, besides the fact that you separate the code in different modules, now what you can do more than that is decide that you can basically build an image of the application only with some certain modules. So with that, you not only better organize your application, but you also minimize the footprint of the application by delivering only what is precisely needed. And of course, I will tell you later why this is a very important fact, not only for monolithic applications, but I wanted to actually clarify these two differences in terms of monolithic applications for now. The Jigsaw modular system, from this point of view, it offers better possibilities in terms of keeping your monolith better organized, but also be able to only deliver what you need in case your application only need to deliver a part of your application to your specific customer. Remember that one of the main concerns of the monolith was that you can't separate the functionalities. They are inside the same process. But remember the story I told you in the previous episode, where I worked on an application that it had maybe 50 modules. And when it was deployed at a specific customer, one customer or another were only using maybe 3 of them, other customer was maybe using 5 of them, another one was only maybe using 1 of those modules, and there was no possibility to separate the modules, and you always had to deploy a 2 gigabytes monolith to that customer, even though they didn't use all those 50 modules. But with a Jigsaw, it's much easier basically to only create a custom image. So why JDK modularity matters? It's not packed in our jar, is external thing when running your app. Well, yes, it basically, when you discuss Java 8, I was telling you also last time that you had in Java 8 what was called a monolithical jar file that was called RT-jar. That RT-jar was basically containing everything. It was a 60 megabytes jar that you always had as a dependency. If you just look here, this is external libraries, it's just a dependency in the class path. So the JDK, it's not like part of the JVM, no, it's a dependency you have. And now, because it's modular, you can actually choose to have only the Java base module if you'd like. That's the only one mandatory, by the way. Or you can choose to have only Java base and, I don't know, Java logging, because that's the only thing you need in your application. And you don't need to have everything else. So instead of having always to put in your dependencies that 60 megabytes of JDK, you now just maybe get 3 megabytes because that's the only thing you need from the JDK. So it allows you to decide that. How do you build Jigsaw modules without Maven? Basically, Jigsaw and Maven are totally unrelated. You can make this application modular. This application, yes, is the second one, modular, and you don't have, as in my case, Maven. That's why I wanted to separate them to avoid confusions. It's called JPackage. Is a tool that appeared with Java 9. I don't want to get into details now about that one because it's too much unrelated to the subject of our stream. Maybe I will create a separate video about that. But as an idea for you, if you want to now go and dig a little bit more, search for JPackage. You will see it's a tool that appeared together with Java 9 and with the Jigsaw modules, and that allow you create your separate your custom image in terms of what your application uses for the JDK. I hope that answers your both of your questions. And does Jigsaw work same as Maven multi-module? Well, no, that's basically what I was explaining here, is that they don't work quite the same. No, one of them only allows you to better organize the application, while the other one allows you a little bit more from this point of view. It's not only a better organization, but a little bit more things. You can, if you joined us later, you can take the video and review it, and you will see that I explained this. Super. So I hope now I clarified those questions I had in regards to our second episode, and I can continue discussing further software-oriented architectures. Software-oriented architectures appeared basically as an evolution of the monolithical approach, because remember, the monolithical approach was the first one, and once networks basically became more usable, we started to have the opportunity of having multiple applications easier communicating one to the other, where of course they were communicating using the network. So I'm going to actually just take this out and explain that, for example, in case of my monolithical application, everything was the same process. We had all the functionalities there, no matter if you design them as modules or not. Everything was in the same process, and you couldn't at least separate them in terms of execution. I just shown you a way in which you can customize the monolith, but you can't just decide to run these functionalities independently. While in case of software-oriented architectures, we discuss of having the responsibilities apart in services. And I would like to actually tell you that there is no perfect system in which a service only has only one responsibility, but in general, now the whole idea is that instead of having one process providing all the functionalities, now you have multiple processes running independently that offer those responsibilities. So I have another question. Does monolithic leans towards Java jars rather than wars? For example, a service as a jar instead of a war. Oh, that's an interesting question, and the interesting question is because I would have first to define what a jar and a war is. A war, defined as a web archive in Java, is basically what we used to deploy in an application server. In an application server, some examples being Glassfish, WebLogic, WebSphere, they basically, in general, can say resemble more to monolithic architectural styles because they somehow allowed you to create your logic, pack it as an archive, and then deploy that archive into a big monolithic application server that acted as a container. So yes, when we discuss WARs, mainly even that's an implementation, and I usually prefer to avoid discussing implementations as linked to a specific architectural style, because sometimes the same implementation can be both can be associated to multiple various architectural styles. In this case, thinking of a normal Java EE application, the way we used to have it maybe 15 years ago, it was rather a monolithic approach, because you were deploying these WAR files in a big container that was the application server. While today, mainly we create what we call fat jars, and that's a terminology you will often hear with Spring Boot, where you pack the servlet container and only the features you need from it together with your business logic, and then the way I will explain later, that is more related to software-oriented architecture. But now, allow me explain before going too deep into implementations. I still first like to discuss with you the approaches, because it's really important you first understand the picture and have the picture of it before discussing implementations. You will see I've in my experience, I've seen many developers making as I did for the monolithic approach. I would like first to discuss the software-oriented architectures without linking it to any technology or solution, and then go a little bit and find out some examples from the Java ecosystem and discuss what and how can they work to maybe solve different concerns that we have with these architectures. So that's what I want to show you. So I was here saying that the functionalities are now services, and of course the services, this functionality is now separated in their own service. They still have to communicate one to the other. So you'll always have cases, situations where you need to make your functionalities communicate one to another. So that's why, for example, in case of a monolithic application, it was very tempting maybe to make your application miserable, muddy, not clean, because simply you were tempted just to link the features wherever you wanted without thinking of a right approach. And that's why modules allow you see better when you link the features and when you link different domains, so that you can decide maybe again to use a contract when you do so. But now discussing about communication between the features, when we were in a monolithic approach, the communication between two features was nothing more than calling a method, creating an object, maybe call one of its behaviors, but it was basically just communication directly done inside the same process. So it didn't need any kind of data exchange through a specific environment. Everything was directly in the application itself, because these three were basically part of the same process. But now, if we separate them, now the first concern, because I would like to get again, so I will say here benefits and then concerns. So discuss them line by line, benefits and the concerns for the service-oriented architecture. Maybe it's better to just put it here. So this is what we discuss now. Benefits and concerns of SOA, which is software-oriented architectures. Cool. So comparing it to the monolithical approach. We have a benefit now that is as in the kind of a modular monolithical application. Definitely now, because you have the functionalities completely separated, it's less tempting to couple too much the responsibilities. Then another difference is that it's easier here to have different versioning for each of the features. That means because they are separate applications, you don't need to change the same application for any of the features you change. If you only change F1, then only this application is changed, which means that you will have independent versions for each of your features. So I can say here, easier to change a feature and independently version each responsibility. So this text is still too big. Let's make it a little bit smaller. Good. Now all the applications here, first of all, they are smaller anyway. As long as you separate the features, definitely you will get smaller apps, smaller pieces of apps than if you would have all the features together. So being that they are smaller, one of the benefits is definitely the fact that the footprints of the applications are smaller, so deployment is easier from the point of view of the application's footprint. So deployment is easier for one app, and that's because the footprint is smaller. And of course, in terms of deployment, you can only deploy the part of application you need, and in case you change any responsibility, you only deploy the piece of code that you changed. So of course it's not literally the piece of code that you changed, is the application containing the piece of code that you changed. But say you have 100 services and you changed only one feature which is in one of the applications, then you really need to deploy only that application. You version it independently and you deploy only that part of the application. So if we think in terms of service-oriented architectures, definitely the maintainability is easier if you know which is the responsibility, and if you from the beginning correctly identify the responsibility for each of the components. It's easier to deploy, it's faster to deploy because F1 has a smaller footprint. It definitely compiles as well as starts up faster than if you had the whole application. It's easier to correct a mistake or a bug because you simply just need to deploy the application where you did the change, or the applications, but usually there won't be all of them. So it's faster to correct, for example, a critical bug than if you had a monolithical application. Definitely more easier to test your applications. And also concerning failures, if one of the applications fail, then it might affect other apps that are dependent on it, but in the huge system it's not necessarily that will affect the whole system. So if your F1 application has a problem and maybe even it's failing, not starting up for some reason, lost the connection to its database, lost the connection to, anyway, if it has a problem and it doesn't work at all, it's it and maybe a few of the others directly dependent to it that will be affected, but you will still have a big part of the system still working. So that's a very big advantage, because if you have one big monolithic application and you have an organization with 10 departments and all the 10 departments use the features in the monolithic application and the monolithic application fails, then suddenly all the departments are blacked out and they cannot work anymore because they wait for the monolithic application to be solved because that one isn't working. But if you have services and for some reason one of them has a specific problem, then it might be that maybe one or a couple of the departments of the organization can't work, but the others can still work fine. And maybe even those departments that don't work, they might not be completely blacked out. So that's a really important thing in terms of deployment. So Vishal, SOA, which is service-oriented architecture, you hear the service in service-oriented architecture and the microservices, which again is a service. Microservices is actually a particularization of SOA. So that's why it looks for you very similar, because it's not two different styles. When you say microservices, which I will discuss in one of the next videos, is just a particular way of implementing service-oriented architectures. So basically, microservices is in a way service-oriented architecture. So that's why they look to you very similar, is because basically they are kind of not the same thing, but they resemble one to the other. Microservices are service-oriented architectures. Not all the service-oriented architectures are microservices, however. So one of the way works, but the other it doesn't work. Okay, so microservices is a kind of service-oriented architecture, but not all the service-oriented architectures are microservices. So I hope I was clear. And of course, when we go further in the next episodes in microservices, I will discuss what are the things that needs to be fulfilled by a system to really be microservices and not any kind of a service-oriented architecture. So yeah, but that will be in one of the next episodes, because you see there are plenty of things to discuss, because of course software architecture is a huge tome, and we will have a lot of episodes discussing these nice things that from my point of view any developer and any IT people should know in general. Yes, and only benefits? No, unfortunately we don't only have benefits with software oriented architectures, we have also concerns. So I was starting basically earlier with discussing the fact that the functionalities now are basically different services, so they have to communicate over the network. So guess what's one of the most important one of the most important or most relevant maybe concern you'll find with software oriented architectures is the communication over the network, because you will learn rule of thumb is that the network is not 100% reliable. So even though today we have networks that are definitely better, faster, allowing more data to be transferred, and that's why we could evolve from monolithic architectures to software-oriented architectures, still the network, any network is not 100% reliable. So that's why we always when having services have to consider what happens if basically the communication between two services fail, which was not the case in the communication between two features in a monolithic application, because there the features were only communicating inside the same process, so you didn't have this concern. Scalability is also a benefit. Basically scalability is a consequence of the fact that is easier to deploy, but I would mention it now that you asked that question. I would like to mention the fact that is less likely to have statefulness, and not that's impossible to have statefulness. Of course, you still might be tempted to implement stateful processes, but because the code base is smaller, it's, in my experience, more easier to spot if you do something like that, and you at least see it easier, and you take the responsibility if you do something like that. But anyway, being less likely to be stateful as a service, together with the deploy, the easiness of the deploy in terms of having a smaller footprint, as well as the fact that you only need to deploy the piece of code you changed, that makes the applications, the service-oriented architectures, the services in a service-oriented architecture, indeed easier to horizontally scale. And maybe we need somehow to mention this. So this three, actually not only this, but I will put it in parentheses here. I will say easier to horizontally scale. Of course, easier than a monolithical approach. Scalability and availability should be both, I guess, indeed, because once you can scale horizontally easier your application, then it's also easier to assure availability, because you can, and that's, I will explain deeper in principles that assure scalability and availability in one of the next episodes. Now you can basically have multiple instances in different availability zones and even different regions in a cloud system. And again, as I will explain deeper in one of the next episodes, this of course, as Bogdan says here, offer you the possibility to easier offer the availability of the applications. But remember that now what we discuss is I'm taking the architectural styles and I'm discussing benefits, concerns, and different ways different ways to mitigate the concerns. And then I will discuss stuff that's related to each of the architecture, like communication, persistence layer, and so on. And then in the next episodes later, I will take all these software qualities, scalability, performance, security, availability, maintainability, and so on, and I will then discuss based on each of the software quality, based on what we learned in the previous episodes. We will take all these software qualities and we will analyze from the perspective of the software quality and what we discussed. So that's my plan. That's how I will teach you in this series of episodes the fundamentals of software architecture. So I'm now taking the architectural styles, we discuss benefits, concerns, we discuss then related things to the architectural style like communication, persistence, and so on, and then we take each of the quality independently. If we maintain a user live data with respect to a functionality in session or in a DB table, does that represent statefulness? In a session, yes. As we discussed in the previous lecture, in the database, probably no, because you are then doing blackboarding, as we discussed in the previous episode. Okay, communication over the network, that's a concern, of course. Consistency of the data. Maybe now you are wondering what has the consistency of the data have to do with the architectural style. Well, you have the possibility to link everything to a database, but when you have, and depending on the architectural style, the kind of software-oriented architecture you use, you might have the situation where your apps have their own databases. And in this case, combining the fact that you have the data separated in multiple places with the fact that errors can independently occur in the services, like for example the communication between the services, what you will find out is that a service-oriented architecture sometimes implies the possibility of having inconsistent data in the multiple sources that we have. And this is a complex concern that we will take separately when we discuss the persistence, the data persistence layer, but it's a very important one. Usually you don't get something like that with a monolithic application, because usually monolithic applications are designed in a 3-tier style where you have one database, the monolithic backend, and then maybe a monolithic front end. And then I have that should be related only to shared resources, right? I'm not sure exactly what the question is, but I guess you are still debating that statefulness. But again, based that I discussed statefulness in the episode 2, you can just review it and let me know later if you have any questions in the comment section. So this is these are some complexities that we have. Now, do we have any other concerns? Yes, the complexity of overall deployment. So maybe you will be now confused, because I just said in the benefits that deployment is easier for services, and now I come back and I say also that deployment is more difficult. How is that? No, deployment of a specific service is definitely easier, because when you deploy only, you say change only F1, which is in our case one of the services representing one functionality in the system, one responsibility, then it's definitely easier to only deploy that one. But when we discuss the overall deployment, then it makes the things a little bit more difficult, because first of all, now you have multiple apps that communicate one to the other, so you have to consider what happens when one of them is down if you deploy them, because that one won't be accessible, or of course depending on how you do the deployment, you might get into a situation where it is not accessible, and of course you don't want that. And that's why in one of the next episodes we'll discuss orchestration and orchestrating the deployment of apps. Another thing that I often see in real world scenarios is that developers tend to change applications without considering a contract between them, and by that I say they tend to change one of the applications in terms of how it communicates to another, and then have a problem with the communication between the two apps, and they have to basically redeploy instead of only one functionality because they change contracts. They have to deploy more apps just to basically change something in one of the responsibilities, and this is something you would preferably like to avoid when you work with services. So if you define strong contracts between your services, you will see that not in all the cases, but in some cases this is avoidable. So that I will say the overall deployment, and when I say overall, then I basically referred here to all the services, is more complex than in the case of the monolithic application, because when you had a monolithic app you only had one process, so it's only one app, you have just to spin it up, you don't have a lot of concerns of it communicating with somebody else, and that basically makes also the application more complex in terms of overall deployments when you have it designed as services. And then when it comes to one application, it's easier to document it and it's easier to understand its responsibility. But what happens now and then is that if you are not careful with how you design your services, you might get into a specific anti-pattern that we call now ravioli code. And I'm definitely sure you might heard about anti-patterns, and you might know that we have spaghetti code. I even mentioned spaghetti code a few times with monolithical applications. When you basically link and couple too much the functionalities, the links between them they basically might they basically might form a spaghetti. Like you don't actually find anymore what communicates with what in the functionalities, in the responsibilities of your application, or you might design that kind of application with multiple layers, where some layers are basically not necessary, and that's what developers call lasagna code in terms of software architectural anti-patterns, because you basically have a lot of layers like a lasagna, and not all of them are actually needed. So you just, some of those layers are how we call them, phantom layers or poltergeists. And the same is with services. They can become ravioli, which is another kind of pasta food, where you basically have the responsibilities split in an unnatural way, or maybe even too much, and instead of making the overall functionality easier to understand, it basically makes it more difficult to understand overall. So now you are less tempted in following in a spaghetti code or lasagna code anti-pattern, because you have the functionality separated in services. But it might be more tempting for you if you are not attentive, and if you don't know how to properly separate your domains to get into a ravioli code. Onion is basically, it's probably the same as what I call the lasagna. I prefer to keep the lasagna term because because you have spaghetti and you have ravioli, you can have lasagna in between, so all of them are pasta food. But if you want to call it an onion, yes, you can have multiple layers like the onion, but it's the same thing. And more or less I can say that we listed the benefits and the concerns, and what I want to do is, in the next episode, like we did for the monolithical approach, because the benefits are okay, we like them, we love the benefits. If we could have only benefits, that would be awesome, but what we dislike is the concerns. And again, in the next episode, I like to take the concerns and discuss the concerns one by one. So why is communication over the network a problem? Of course, because network is not 100% reliable, but what can we do about that? What are our options in terms of how we make the services communicate one to the other? You will see we have plenty of cases. We can use and REST endpoints or any other kind of procedural calls. Is it the procedural call done via REST, or maybe you would like to use GraphQL? Maybe we want to implement some messaging oriented system. You might use JMS, or you might use Kafka, and all of these have their own benefits and concerns, and we want to discuss them. And then of course we will take the persistence layer and we will discuss consistency and why is that a problem. And we will also have to discuss how we make our overall deployment less complex by using, for example, orchestration. So there are a lot of things we need to discuss, and that's what we'll basically, in the next episode, take the concerns and discuss the concerns as we did for the monolithical approach, and see what can we do to minimize the impact of the concerns in this for this architectural style. And before ending, let's see, do I have any other questions? So do the service owners run their own servlet containers instead of all three apps running in the same app server? Yes, that's why they are called services. So to be more precise, they are the independent applications. Services are independent applications, no matter if they are web applications or not. They can be something else than web applications, but when we say services, it means separate applications, separate processes. Then okay, and can front-end code also be developer SOA principles? Although from what I know, yes, I'd like to be able to say more on that, because I actually I've seen a lot of the presentations, and I enjoyed a lot of presentations in terms of what we call micro front ends. And I will describe at some point in one of the next episodes, I will tell you a little bit more of what I understood in terms of micro front ends. However, I would like to add a disclaimer and remind all of you that I'm a mainly backend developer, and even though I know some front end and I worked on some front end, I don't want to anytime claim I'm a front-end developer or a full-stack developer. So I will try to share you my knowledge on micro front-ends, but I would like to also advise you to try to find more advisable people on this area if you want to go deeper than what I know. So the answer is yes, I will try to tell you more about that, but remember that I'm not an expert in front-end, and I will only tell you what I know from the perspective of a backend developer and of kind of developer taking the technical architect role in some projects. And then we should use 3-layer architecture in creating a service too. In three-layer architecture, meaning probably having database, then the service, the business logic, and the front end. And you can see it as a 3-tier architecture, but is it actually a 3-tier architecture? I never think about an architecture as being three-tiered when I design services, just because, as you can see, you might have the database separate, the persistent layer separated, so it's not only one anymore. You can think at it as one, but is it actually one? It's hard for me to see it that way. Maybe it's easier for you to see it that way, but for me, for example, it's much more difficult, so I prefer to not consider it a 3-tier anymore, because even though you still have persistence and you still have business logic implementation, but that's now separated in multiple services, and probably you still have a front end, it being this separation of the business logic as well as sometimes also the persistence layer, I avoid, and it's much more difficult for me to see it as a 3-tier. So I hope I answered your question. But what I learned is that different people find ways easier to perceive and understand in different ways. So maybe for you it's better to still think of the persistence layer, sometimes the business logic layer and the front end separately, and then each of them being its own separation as well. If that's better for you for understanding, then you can think about it that way. If 3 services created as a separate web apps has single DB, does that follow SOA standards? Yes, if it has only 1 DB, then it's still a service-oriented architecture, because when we discuss service-oriented architectures, we don't anyhow think about how the persistent layer looks like. So in my case, I just separated, say, my responsibilities. In my case, I can have, for example, F3 here, just connecting to the database, and then I have the same database used by F2, and this is something that we still consider a service-oriented architecture. While in case of what we'll discuss in a later episode, microservices, it's not the case. But again, we discuss microservices later after we discuss the general approach of having multiple services, because it's easier to start with the service separation and then go further on more particular way of implementing service-oriented architectures such as the microservices. Thank you very much, everyone. Also, thank you very much for being here with me today as well. I will end up this session now, and I think we already discussed plenty of things. I don't want to get you bored. In the next episode, we are going to take the concerns on the service-oriented architectures, discuss them, dissect them, see what questions you have, and of course, demonstrate whatever we can demonstrate. Until then, thank you again, everyone. Have an excellent time for study further, and cheers!